A circuit with multiple loads can be connected in series or parallel. In a series circuit, the current is constant throughout the circuit. The sum of the voltage drops across each resistor will be equal to the voltage supplied by the source. The total impedance of a series circuit is found by adding the impedances of the individual loads. The more loads added to a circuit, the greater the overall impedance. In a parallel circuit, the voltage is constant across each branch. To find the total current in a circuit, you must add up the currents flowing through each branch. The total impedance of a circuit is found using the formula 1 over total impedance equals 1 over the impedance of the first load plus 1 over the impedance of the second load plus 1 over the impedance of the third load, and so on. As you connect more loads to a parallel circuit, you increase the number of available paths and the overall resistance decreases. When confronted with a word problem, it can be helpful to sketch a diagram to help you understand what's going on in the problem and remind you how to solve it. The problem says, what is the total impedance of two 8-ohm loads connected in series? To diagram this, I will draw two loads, also known as resistors, connected in series and label each with 8 ohms. To calculate the total impedance of a series circuit, you just add up the impedance of each resistor in the circuit. For this problem, I will add 8 ohms plus 8 ohms for a total impedance of 16 ohms. I know this answer is correct because the total impedance is greater than either of the individual impedances. In a series circuit, the greater the number of resistors, the greater the overall impedance. This second problem says, what is the total impedance of two 8-ohm speakers connected in parallel? To diagram this, I will draw two speakers connected in parallel and label each with 8 ohms. To calculate the total impedance of a parallel circuit, you will need to use the following formula. 1 over total resistance equals 1 over the first resistance added to 1 over the second resistance. Don't let the fractions fluster you. Take the problem one step at a time. I will substitute 8 ohms for each of the impedances. The fractions on the right side of the equation have a common denominator, so I can add them together. 1/8 plus 1/8 equals 2/8. Rewriting the equation after calculating something like this will help reveal the next mathematical step and prevent you from making errors. Now I see that 1 over the total impedance equals 2 over 8. Mathematically, I can take the inverse of both sides and flip the equation. Now I have a total impedance equals 8 divided by 2. So my total impedance is equal to 4 ohms. I know this answer is correct because it is smaller than either of the individual resistor values. If you have two unequal loads connected in parallel, it can be easier to use decimals instead of fractions. In this problem, I have a 6-ohm load connected to an 8-ohm load. I will use the same formula as in the previous problem. This time I'll substitute 6 for the first impedance and 8 for the second. Instead of finding a common denominator, I'll divide 1 by 6, which gives me 0.1666667. I'll round that off to 0.167. 1 divided by 8 gives me 0.125. Now I'll add up the terms on the right. 0.167 plus 0.125 gives me 0.292. This equals 1 over the total impedance. To find the total impedance, I must take the inverse of both sides, which is a fancy way of saying put 1 over on both sides. On the left side, I have total impedance, and on the right side, I have total impedance equals 3.4 ohms. Once again, I know this is a reasonable answer because it is less than either of my individual resistors. Sometimes you are faced with circuits that are not exclusively series or parallel. They are a combination. You can spot these problems easily because they use words such as series and parallel, or they use the word combined. This problem states a circuit has two branches. The first has a 4 and a 6 ohm load connected in series. The second branch has three 8 ohm resistors connected in series. What is the total impedance of the circuit? You should be familiar with both the terms load and resistors. Some people in text have a preference for one or the other. The terms can generally be used interchangeably. The first step to solving the problem is to take a few moments and diagram your circuit. Drawing a diagram will help you understand how the circuit is constructed and avoid silly math errors. The word branch refers to a parallel circuit construction. Since the problem says I have two branches, I will draw a parallel circuit with two branches. The second part tells me what is in each branch. On the first branch, I will add a 4 and a 6 ohm load. On the second branch, I will add three 8 ohm resistors. Resistors can be added in series or parallel, but never both together. To solve a combination circuit, you have to identify the series and parallel constructions within it. In my diagram, I see two series circuits within my overall parallel structure. So my first step will be to add up the series circuits, and my second step will be to add up the branches of the parallel one. For the first branch, I add up 4 and 6 ohms for a net impedance of 10 ohms on that branch. On the second branch, I add up three 8 ohm resistors for a net impedance of 24 ohms. Once I have solved part of the circuit, I find it helpful to simplify the circuit and redraw it. So now I will draw a parallel circuit with two branches, the first with an impedance of 10 ohms and the second with an impedance of 24 ohms. Looking at my new diagram, I see a simple parallel circuit. The next step will be similar to the last problem I solved. I will substitute 10 and 24 ohms into the parallel impedance formula. I will solve the problem step by step to avoid making careless math errors. 1 divided by 10 equals 0.1. 1 divided by 24 equals 0.0417. Adding up the right side gives me 0.1417. Take the inverse of both sides and I get a net impedance of 7.1 ohms, rounded of course. I know this impedance is a reasonable answer because it is less than either of the parallel branches.